In this first section, we're looking to solve logarithmic equations using exponentials. So I made a note that says use exponentials to undo logs. So what we're doing is we're creating an exponential with the same base. If you look at the first example, I use 10 as the base, and I make log my exponent because log has a base of 10 if there's nothing there, so technically there's a little 10 down there. That will cancel out the logarithm, and if I do it to one side, I have to do it to both sides, and that cancels out the other logarithm. So these first 5 problems are very simple because you end up just setting one equation equal to the other, and we can also use the looking inside method. Since the logs match, we want the insides to also match. So I posted an answer key that you guys can go review and check your answers 1 through 5. It should just be simple algebra. Number 6 is when we have to start isolating the logarithm. So if you look, there's a multiplier of 2, and I chose to divide by 2 first. And then we can undo our logarithm with the same base, or we can rearrange it to say 7 to the 0 power is equal to negative 2r, which you'll notice I got 7 to the 0 power is 1, is equal to negative 2r. Divide by negative 2 and you get negative 1/2. So I'll show you both ways how to do this next one as well. You get to choose what works best for you. So we want to isolate the logarithm. Any other algebra outside of that, let's take care of it. To get rid of minus 10, I'm going to add 10 to number 7. And I'm going to get log base 3 of n plus 3 equals negative 10 plus 10 is 0. If I want to do it mathematically, I'm going to raise both sides and use 3 as the base to cancel out the log and get n plus 3 equals 3 to the 0. I can do that, or I can look at the pattern and say 3 to the 0 power equals n plus 3. Either way is fine, whichever way you prefer. I'll leave the 3's there for now to show you the math. And then 3 to the 0 power, anything to the 0 power is 1, so n plus 3 equals 1. Subtract 3 and we get n equals negative 2. For number 8, we're going to start by dividing by negative 2 to get rid of the times negative 2. We need to do it to both sides. So log base 5 of 7x equals negative 1 now. I'm going to do 5 to the negative 1 equaling to 7x. So I'll show you the other method. A negative exponent will create a fraction, so I have 1/5 equal to 7x. Divide by 7. Division goes in the denominator, so I get 1 over 35 equaling to x for number 8. Let me shrink that work for you here. Get that out of the way. You guys will get the point on that, I hope. Alright, let's look at the next one. We want to get rid of any algebra outside of the log, so I'm going to subtract 2 to get rid of plus 2. So my log of negative m is equal to 2 now. If I subtract 2 from both sides, log without a base is a base of 10. So 10 squared is equal to negative m. Oops. So I did 10 squared equal to negative m. 10 squared is 100. If negative m is 100, then positive m equals negative 100. I'm going to switch up some color here for you. Get rid of the negative 6 by dividing by negative 6. So I get log base 3 of x minus 3 is equal to 4. 3 to the 4th power is equal to x minus 3. 3 to the 4th power is 81. And if I add 3 to that, I get 84. So x is equal to 84. Okay, now we have logarithms on both sides of the equations again, and they're the same base, so if I use 12 to cancel out both like the beginning, I'm going to end up with v squared plus 35 equals negative 12v minus 1. Now we're back to solving algebraically, and if you forgot, we have v squared and v. We need to get one side equal to 0 so we can factor. Yeah, that came back for you. That's going to keep coming back. So v squared plus 12v plus 36 is equal to 0. Now I can factor v plus 6 times v plus 6 is equal to 0. And I'm going to get v equals negative 6. You can refer back to our factoring notes if you need help with that. Bottoms up, box and diamond, whichever way you like to factor is fine with me. Raise both sides with a power of 9, or sorry, a base of 9. Cancel out the log base 9. And we're going to have a similar scenario here. Negative 11x plus 2 equals x squared plus 30. I like to keep my x squareds positive, so I'm going to move this stuff over here to get 0 equals x squared plus 11x now plus 28. X plus 7 and x plus 4 are my factors because 4 times 7 is 28 and 4 plus 7 is 11. So I'll get two solutions here. X could equal negative 7 or negative 4 using zero product property. Again, on this one, it's going to look very similar. There's my setup because I got to cancel out my logs with a base of 10. And I want to keep b squared positive, so I'm going to say b squared minus 6b minus 16 is equal to 0. I moved this stuff over to the right side. And if I factor that, I should get b minus 8 and b plus 2. And then my two solutions will be positive 8 or negative 2 for b. And another one here. Hopefully we're getting the hang of this. N squared plus 12 equals negative 9n minus 2. Again, the ln just means natural log. It's just a special base. Like log has a base of 10 if we don't write something. Natural log has a base of e. It's a special log that we will use in some application problems. I'm going to keep n squared positive, so I'm going to move everything to the left side this time. N squared plus 9n plus 14 is going to equal 0 this time. Looks like I'll get n plus 7 and n plus 2 equal to 0, which would result in a negative 7 and a negative 2 from my solution. Alright, so then the next set here have multiple logarithms on one side, and we can't necessarily start raising it to a power yet. We need to first condense the logarithms into one location. So you'll see that I used the product rule here and multiplied the terms together. Then I rewrote it as 10 squared equals 8x. 10 squared is 100. And then 100 divided by 8 is 12.5. If we want to do the same with 16, we're going to use the quotient rule. Log of x over 2 is going to equal 1. 10 to the first power is going to equal x over 2. 10 to the first power is just 10. I'm going to multiply each side by 2 and get x equals 20. Switch up the color here. Product rule on number 17, we have log of 2x equal 1. 10 to the first power is equal to 2x. This time we're dividing by 2, so x equals 5. Log of 7x equal to log of 37. If I simplify both sides now, we can raise both sides with a base of 10. 7x equals 37. You can leave that as a fraction if you'd like to. 37 over 7. Got a log base 8 this time. If we condense that, it's log base 8 of 8x squared equaling 1. So 8 to the first power here is going to be equal 8x squared. Divide both sides by 8, we get 1 equals x squared. Take the square root and we'll get positive or negative 1. Condense these using the quotient rule. X plus 6 over x equals log base 9 of 2. I can drop the logarithms now and use a 9 as the base. Cancels them out. And I get x plus 6 over x equals 2. So now if you notice, x is in the numerator and denominator. If I multiply by x, it gets rid of it on this side. We have 2x on this side, so that'll help your problem look easier. Now we can subtract x to get x equals 6. These two logarithms can be condensed using the quotient rule. X plus 1. This is going to look very similar to the previous problem. So we get x plus 1 over x equals 29. Multiply by x to get x plus 1 equals 29x. And then 1 equals 28x. If I subtract x from both sides, divide by 28, I get 1 over 28 for x. And you can double check my answers, make sure I'm doing them all correctly. Look through the answer key, that should help. I forget where this 2 was, I'm so sorry. Alright, if we look at the next problem, we have log base 5, 6, so we can multiply those together using the product rule. 12x squared equals log base 5 of 48. I apologize for the sloppy handwriting. I can drop both logs on each side and say 12x squared equals 48. Divide by 12, I get x equals 4. Sorry, x squared equals 4. Take the square root, x equals plus or minus 2. Wrote you a little note to make sure you remember natural log just means log with a base of e, the natural number. So these are going to be no different than the ones prior. Except we're using e as the base. So you notice that I left e as a final solution here. You can leave that or you can type it in a calculator. This is called our exact answer and this is called our approximate solution. If I condense these logarithms, I can condense them into 1 using the quotient rule. Negative 3x minus 1 over 7 equals 2. This is a base of e, remember, so e squared is going to equal this stuff. E squared equals that stuff. I'm going to start by multiplying by 7 on each side to get 7e squared equals negative 3x plus minus 1. 2 more steps. I'm going to add 1, then divide by negative 3. And I'm going to call that my final solution. The answer key should have the decimal. You can double check yourself, type that in the calculator and see what's happening. Condense the logs here. Drop the natural log on both sides, and we'll get x minus 3 equals, over x minus 5 equals 5. Multiply by x minus 5 on both sides. We'll get x minus 3 equals 5x minus 25. I distributed. Subtract x from both sides, I get 4x. Add 25 to both sides, I get 22. 22 divided by 4 equals x, and that's going to be 5.5. Hopefully you can look through the answer key with number 26. I'll try to squeeze this work in here. I'll use red ink or something. Alright, so we can condense the natural logs first. 4x plus 1 over 3 equals 5. Now we can rewrite this as e to the 5th. Remember, that's an e as the base, equals 4x plus 1 over 3. We're going to multiply by 3, subtract 1, and then divide by 4. That'll tell us what x is.